Okay, what we have going on here is I have my 5 test tubes. I got a bunch of other test tubes. I got my 5 labeled, 1, 2, 3, 4, 5. I got my samples of the iron, the SCN, some distilled water, and then the 0.2 molar Fe. And I got my pipettes already clean. That's actually why I have all this water, because I filled that up with distilled water to clean these out. And they've already dried out or drained out, and we're good to go. So I'm ready to start putting this stuff together. All right, so my first pipette, I'm going to use this with my 0.002 iron. Is it 0.002 iron? And I want 5 milliliters of each of it into each of my first 4 test tubes. Now these particular pipettes, they go down at 9 and then out, so I am going to fill this up to 5 and then just let it drain out totally. Now technically, since this is all the same, I could have used like a volumetric pipette where there's just one line and just filled up every single one of them to 5. All right, 5 into test tube 1. Another 5. Test tube 2. Another 5 for test tube 3. And the final 5 in test tube 4. All right. I am done with this pipette. I will need to clean it. I don't want to put up my others. And move the paper towels out of camera view. Put it over here. All right. That was our iron. And I did have some left over, but I did fill it roughly to the 30 mark here with this Elmeyer flask. But you'll find that those numbers were put on with drunk, blindfolded workers, so those numbers are never useful. All right, next one is the KCN, which is my second vial here. The first test tube is getting 2 milliliters from this. So I'm going to fill this line up to just 8. And we immediately see that complex form. Test tube 2, sorry, gets 3 milliliters. Filling this up to 7. Test tube 3 gets 4 milliliters. And test tube 4 gets 5 milliliters. And we're not done with this one, because technically it's on the next page, but test tube 5, our control, gets 1 milliliter, and I'm just going to go ahead and put that into test tube 5. then I can retire this pipette. All right, done with that pipette. All right, now the next thing I'm adding is water. And it's going to be 3 milliliters in the first, 2 in the second, 1 in the third, and none in 4 or 5. Now, if I used all the exact same test tubes, which I didn't, your levels would be identical when they're all done. But I went with cleanliness. Missed it. And finally, 1, and then we're done with water. And then the last thing, I grabbed some 0.2 molar of the iron. I'm going to put 9 milliliters of it in test tube 5. Oh, I clearly didn't grab enough. Oh, yeah, I did. What luck. All right, so I have my 5 test tubes. To stir them up, I'm just kind of flipping it by holding kind of tight at the top. Get that color uniform throughout. The first ones definitely have a little bit more of a difference. Here we go. All kind of mixed. Now we're ready to put them into our cuvettes. Our cuvettes are these nice little clear things. Got some ridge sides and got some clear sides. You'll only ever want to touch them on the ridges sides. Now, best way to actually do that is with some disposable pipettes. But for some reason, I don't have any. So I'm going to actually do it the really old-fashioned way and be careful in pouring it in. So, number 1. And going about 3/4 full. Yeah, that should be enough. And these are, it is kind of funny, students in the past have labeled their cuvettes, but if they didn't like the numbers, rather than erase the previous ones, they wrote over top. So I'm just going to keep track of them by putting my cuvettes in front of the test tube that I want. So you can't see them, but they're there. And 5, the last one. All right, got all our test tubes filled. The 6th one, we're going to put some distilled water in it. This is going to be our control. This is how we balance it out or zero out our cuvette or the calorimeter. And it's kind of obvious it's the control because all the other ones have that blood red color to them. My computer computer reset. All right, the screen did come back on. Apologize for the color. It's warm in the lab. I have a feeling that's what's going on with this. All right, so I already set up my colorimeter. It is good to go. It just needs to be calibrated based on our blank. Our blank is actually water, and I made too much turbulence when I poured that in, so I got some air pockets in mine. All right, got them. All right, but I don't just put this in like this. We have these little chem wipes. Clean the clear sides. And then in the top of this, depending on which one it is, there's going to be a little arrow. You want the clear part to line up with the arrow. And since this is our blank, when I close that, when that absorbance stops changing, we just hit the CAL button on. That's for calibration. And if all goes well, right, the absorbance drops to 0. All right, that's the last thing we have to hit. Now, what we're going to do is just go right in order. Pull that out, and I'm going to put the next one in. I'm going to clean off the sides. This is number 1. Close that lid. We're going to let this stabilize. Now, I'm going to do a couple things so we see all these data. I'm just going to hit collect. Now, I'm not actually going to collect any of this data for real. When it stabilizes, I'm going to write down the absorbance on this screen. Now, I thought I was going to have a problem with these colors, and I think I am going to have it. My dilute iron is too concentrated. I'm not going to type in the right concentrations here. I'm just going to do 1, 2, 3, 4, and 5. So I'm putting in my test tube numbers here. But I don't care about anything other than a nice straight line once everything gets in here. All right, so pull that one out, put our next one in. Let this stabilize. Yeah, all right. I have a problem with one of my chemicals. All right, that's the problem with these type of colorimeters. These are just too dark, and our colorimeters are not strong enough to see through them. All right. I'm going to pause the camera. I'm going to try something else with my colorimeter. Okay, so I did a couple things. First, I got new solutions here. Well, basically, those are the old solutions. I made it again, and that's the color the control should have been. And we had ridiculously dark. So, had the wrong stuff in there. So, I just diluted those. I'm not going to do anything with that because it turns out I have an instrument that'll do a better job. It's a straight spectrophotometer. So, it basically is a brighter light. So, it's going to actually penetrate through there. Now, when I put this in, I actually get my control. And I've already actually programmed this in and done it. And I'm sitting right here. I have highlighted the 480 line, which is what I'm looking at. All right, so it's calibrated. That's why I went back to 0. And then if I put something in here, we'll see that jump up, and I'm getting like 1.340. All right, now just go ahead. I'm not going to do all these right now. I'm just going to go ahead and throw in that control. So you can see that it doesn't max out. It doesn't go to too high of a number or give me an error or just disappear like the colorimeter did. The colorimeter just didn't report anything. We are actually getting a number of 1.94. It varies. I'll have to let that sit and stabilize some, but basically all I did was I just changed my instrumentation. The spectrophotometer, this thing is just putting out a brighter light. This, our colorimeters do a great job, but they just have like little LEDs in there, those RGBs, and it's just simply not bright enough to penetrate through this. Yet our spectrophotometer, even though it's made by the same company, we could probably even mix this with coffee, so you know how dark coffee is, and it'd still be able to penetrate and give us an absorbance. It's just a much better light source. So I'm going to get all the data, and then we'll look at how we process it. I'm not going to do that now. It takes too long to stabilize on that. It jumps a lot.